Hi, it's Alex's World of Math, and today we're gonna be shortly gonna go through a short topic called the principle of nothingness. All right, so let's go to the first example. It's very self-explanatory and it's very simple. So the first example says how many ways are there to tile a 1 by 1 board with two by two pieces? Um, well, this is just zero, right? There's 0 ways to tile a 1 by 1 board with um, 2 by 2 piece. Right? You literally cannot fit that. So that's zero. But then the interesting thing that happens here that the principle of nothingness applies to is how many ways are there to tile an n by n board with 1 by 1 or 1 by 2 pieces if n is equal to zero. So if you have a non-existent board, you're asking how many ways can you tile it using those combinations? Well, you might say zero, but the answer is actually one. Why? Because it was actually already tiled. You can't tile a 0 by 0 board with those pieces, but um, but it was already done before the question. Like once the question was asked, this was already done. Um, yeah, you can't do it after. But there's only one way for this to exist, right? It's something that exists. That is brought up. So there's one way to do it. And that's what the principle of nothing says. It says that there is one way to do nothing. That's basically what it's saying. And so yeah, definition 1.5.1 says that the sum of the elements in a set in the empty set denoted by this symbol um that's equal to the empty set. They're basically saying the sum of items in here is equal to zero. That was the first one. That was the first question where but this basically defines the empty set as unique. It has zero. Actually not unique, but it's just saying that the sum of the items are zero because like despite there being no items, there's no items to sum, so the sum is zero. Um, and for this definition, the next definition, it defines that the empty set is unique, um, because of, um, because of, uh, because of this thing. So you have cardinality of uh, a set of the empty set. If you put that as an element of a set, then that's equal to one. This is basically just saying that it's unique. That this value, this 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 empty set is something. It's a set, it's an item. And so that makes it unique. Um, and so yeah, that clarifies and states its existence. And so there's four other things that you should know, that it's a subset of any set. Obviously, if you have like a set of one and two, uh, if you take the two items out, it's gonna have an empty set. And so the empty set is part of the set. It's part of any set. And the second statement is that the cardinality of it is equal to zero. Well, yeah, that's defined right here. Basically the same thing, that there's zero elements in the zero set, in the empty set. And the empty set, and this is a sum, by the way, this is not the cardinality. The empty set is an identity element for intersection. Well, yeah, the empty set intersecting with any any set. Well, any set, including like any set that is not an empty set, um, will have some elements. And what is intersecting with that? Well, remember in step one we said that it is a subset of any set. Um, so it's bound. So it does have, so every set basically does have the empty set property if you remove all the elements. And so basically the intersection is no elements, which is also just empty set. And if you have an empty set union, I mean, intersecting with, like, if you want to find empty set, intersect and empty set, that's going to be the empty set. This, yeah. And the empty set is, and it's also the identity for union. So basically, any set union with the empty set is that set because the empty set brings zero elements, right? It has zero elements, so it's not gonna have any new area. Like if you have S, the empty set is inside. Well, like it's not existent, so it's not gonna add new area like here or something. So it's going the union area is gonna be S, and that's it. This might be like you might think this might be like useless, but it's actually very important in like linear occurrences, which is a chapter we're gonna talk about later. Where you define that there are one way to do nothing, right? So like it's gonna define like a0 as one for some real life examples. You'll get there, but it's definitely applicable in some situations. All right, and that's all. Have a nice day.